Welcome to the Mahatma Gandhi Institute of Technical Education and Research Center. In 2004, a national level institute AMGITA has been started in the field of engineering and technology as per guidelines of All India Council for Technical Education AICTE New Delhi. AMGITA is approved by AICTE New Delhi, Gujarat State and affiliated to Gujarat Technological University Ahmedabad, which is also known as GTU. Our goal is to be an institute of generative ideas so that we remain relevant to our society. The AMGITA has always been an organization on move with continuous effort on improving its processes and to maintain its relevance to the Indian science scenario, with adding new programs in its programmatic portfolio. We strongly believe in overall development of students, so for that we provide them a different platform like state level tech fest, project fair, different sports activity, which helps students to teach teamwork and problem solving skills to get physical health benefits, boost self esteem, and reduce pressure and stress for prove their skills in distinct area. Welcome to the lecture of Basic Electronics. Myself, Professor Gaurang Patel from Mahatma Gandhi Institute of Technical Education and Research Center, Navsari. So, student, today we are going to discuss about the chapter 1, that is diode theory and its application. So, in this chapter, students, we are discuss these points are in detail. There is second and third approximation for the diode and what is the surface mount diode. Okay, so we will begin with the explanation. Okay, so after that we will see the another point, that is the second approximation. Okay, first हमने क्या देखा कि भाई we will see what is the ideal diode or what will be the ideal characteristic of the diode. Okay, now we will see the second approximation. Okay students, so here what is the second approximation is given over here, that I will show you, just a moment. Okay, so in second approximation, the ideal approximation is all right in most troubleshooting situation, but we are not always troubleshooting. Okay, sometimes we want a more accurate value for load current and load voltage. This is where the second approximation comes in. Okay, so what is second approximation? They are trying to say us, that is, figure shows the graph of current versus voltage for the second approximation, and the graph says that no current exists until 0.7 volt. So second approximation यहाँ पे हमने क्या लिया है कि भाई 0.7 वोल्ट तक कोई भी करंट फ्लो नहीं हो रहा है. ओके, सो अब if current is less than 0.7 volt, your switch is going to be open. ये condition यहाँ पे हमको समझाने की कोशिश की जा रही है कि भाई 0.7 वोल्ट तक कोई भी करंट फ्लो नहीं हो रहा है. So if the current is less than 0.7 volt, so your switch is behaving like a open circuit, or you can consider it your diode is a reverse bias in reverse bias condition. And your if when you get the 0.7 voltage, you will get the conduction of current. You can see this is the diode voltage, this axis gives you the value of diode voltage. So this is 0.7 volt is given over here, and when 0.7 voltage is arrived, this current is going to be sharply increased from this situation. Okay, so up till 0.7 voltage there is no flow of current is given over here in the graph. Okay, so students, इसमें second approximation में क्या कहा गया है कि भाई figure shows the equivalent circuit for the second approximation of silicon diode. We think of the diode as a switch in series with a barrier potential of 0.7 volt. If the Thevenin voltage facing the diode is greater than 0.7 volt, the switch will close, and when conducting, then the diode voltage is 0.7 volt for any forward currents. जो हमने अभी explain किया, that is that exactly what they want to say. Now on the other hand, if the Thevenin voltage is less than 0.7 volt, the switch will open, and in this case there is no current through the diode. So simply इससे कम है तो करंट नहीं फ्लो रहा है, और 0.7 तक अगर रीच कर गया है तो पॉइंट्स तो करंट यहाँ पे फ्लो हो रहा है. ओके, सो दिस इज द सेकंड approximation. And similar thing you can be calculate if the second approximation will be there. So if they are trying to solve you that load voltage and load current, so with the similar approach you can take this Now since the diode is forward bias and it is equivalent to a battery of 0.7 volt, this means that the lead voltage equals to the source voltage minus the diode drop. तो यहाँ पे हम क्या करेंगे, वो आइडियल केस की बात थी, अब अप्रोक्सीमेशन की बात आ रही है तो थोड़ा सा हमें उसमें से चेंज करना पड़ेगा, क्योंकि यहाँ पे हमें 0.7 वोल्ट का यहाँ पे ड्रॉप दे रखा है, ठीक है। हमारा टोटल जो है 10 वोल्ट है और 0.7 वोल्ट हमें तक पहुंच का वोल्टेज हम अप्लाई करने के बाद हमको वहां पे मिलेगा। तो आपका VL जो है लोड वोल्टेज वो क्या होगा, टोटल सोर्स वोल्टेज माइनस your breakdown voltage. So your VL will become 9.3 volt, or similarly for the load current what you have to do, that is 9.3 divided by 1 kilo ohm, so it will be give you 9.3 milliampere. And if you want to interested to find the power, then the diode power is PD, so 0.7 volt into 9.3 milliampere, so you will get the power dissipation of 6.51 megawatt over here. Okay, so it is all about the second approximation. Then we will see after that the third approximation will be there. Okay, so what is the third approximation tell us? The third approximation tell us that in third approximation of a diode, we include the bulk resistance RB. So you can see over here in series there is a bulk resistance RB is given there, that is connected in series with their source. Okay, so after the silicon diode turns on, the voltage increases linearly with an increase in current. Okay, after the silicon diode turns on, एक बार आपका silicon diode है, अगर then once it is start, the voltage increases linearly, voltage आपका linearly increase हो रहा है with an increase in current. Now the greater the current, the larger the diode voltage. Okay, बिकॉज ऑफ द वोल्टेज ड्रॉप अक्रॉस द बल्क रेजिस्टेंस। तो यहाँ इस केस में क्या हो रहा है कि जितना आपका करंट ज्यादा फ्लो होगा उतना आपका वोल्टेज ड्रॉप भी बढ़ेगा, क्योंकि सीरीज में यहाँ पे रेजिस्टेंस दिया हुआ है। तो बट ऑब्वियस अगर करंट के सीरीज में अगर रेजिस्टेंस आप कनेक्ट करेंगे तो यहाँ पे आपका वोल्टेज ड्रॉप भी बढ़ेगा। दैट व्हाट दे वांट टू टेल अस इन थ्रू this circuit diagram. So this is all about the third approximation. In third approximation, what another theoretical statement is given? The equivalent circuit for the third approximation is a switch in series with the barrier potential of 0.7 volt and resistance of RB. When the diode voltage is larger than 0.7 volt, the diode conducts. During the conduction, the total voltage across the diode is VD is equal to 0.7 volt plus this is the voltage drop. So total आपका VD, ये जो total VD है वो कितना मिलेगा आपको, एक तो आपका 0.7 वोल्ट जो आपका बैरियर वोल्टेज है वो, प्लस आपका वोल्टेज ड्रॉप दैट इज ID into RB. ओके, नाउ often the bulk resistance is less than 1 ohm. आपका जो bulk resistance है उसकी वैल्यू less than 1 ohm कंसिडर की जाती है, and we can safely ignore it in our calculation. A useful guideline for ignoring bulk resistance is this definition. So ignoring bulk resistance is less than 0.01 RTH, that is the Thevenin's resistance. Okay, so student, this is all about the second approximation and third approximation. Okay, so from that explanation you can able to answer this question, that is what is an ideal diode. Okay, so we will start with that what is, where it was, I think, yes, yes, it is the what is the ideal diode and what is the characteristic of the ideal diode. Okay, then what we have seen in ideal diode में क्या सिचुएशन थी कि भाई आपका जो करंट है वो 0.7 वोल्ट रीच करने के बाद ऐसे शार्पली इंक्रीज होता है और पहले भी थोड़ा सा ऐसे इंक्रीज हो रहा है। फिर हमने दो अप्रोक्सीमेशन लिए। ओके, देन फर्स्ट इट इज known as a second approximation. The second approximation क्या रहेगा हमारा कि भाई हमारा डायोड जो है वो स्विच की तरह बिहेव करेगा कि जैसे ही 0.7 वोल्ट आते हैं तो वो शार्पली डायोड करंट इंक्रीज हो जाता है। ओके, सो दैट इज द सेकंड approximation or also known as 2D approximation. Then we are saying about the third approximation. Third approximation हमारा क्या है कि भाई आपका जो जैसे जैसे आपका करंट बढ़ता जाता है, यू कैन सी योर वोल्टेज ड्रॉप इज इंक्रीजेस linearly with रिस्पेक्ट टू डायोड करंट, क्योंकि यहाँ पे आपका बल्क रेजिस्टेंस ऐड किया गया है. सो दिस इज ऑल अबाउट द थर्ड अप्रोक्सीमेशन. सो इफ this question is asked in GTU, so you can easily explain with this video lecture session. Okay students, so just a moment. Okay students, so this is the new topic, that is surface mount diodes. Okay, so in this topic we will see how the diodes is going to be manufactured and operate, made, and some different types of uh, diodes will be there. So mainly there is a surface mount diodes, and one more, that is a SOT, that is a small outline transistor. Okay, so surface mount diodes can be found anywhere. Here is a need for diode applications. Okay, अब डायोड का जहाँ भी यूज होता है उसमें सरफेस माउंट डायोड्स ज़्यादातर यूज होते हैं. सरफेस माउंट डायोड दैट मीन्स सर्किट के ऊपर जो डायोड्स हम माउंट करते हैं, दैट इज नॉन एज अ सरफेस माउंट डायोड. सो वो किस तरह से दिखता है, दिस इज द डायोड दैट वी हैड सीन shown, and in that diode there are two leads are going to be extended from both of the ends, दो उसके ends आपको बाहर निकाले हुए दिखेंगे. देन देर इज द माउंटिंग लीड्स, यहाँ पे एक ऊपर इस जो है उसमें से दो लीड निकाली जाती है, और एक यहाँ पे ऐसे कलरिंग इस तरह से एक लाइन की गई होती है. वो कलरिंग लाइन किसके लिए होती है, दैट इज the known that which one is the cathode and which one is the anode. So whatever which place having this line, that side we are known that is the cathode. जहाँ पे ये ऐसी लाइन दिखेगी वो साइड क्या कहलाएगी, उसे कैथोड बोलते हैं. ठीक है. So when you will connect in practical this circuit, just see कि भाई लाइन कहाँ पे दे रखी है. तो जो लाइन जहाँ पे ये ऐसी लाइन आपको दिखेगी वो साइड आपकी कैथोड रहेगी, तो उसको आप नेगेटिव टर्मिनल के साथ कनेक्ट करेंगे, और रिमेनिंग टर्मिनल जो एक रहा है उसको आप पॉजिटिव टर्मिनल के साथ कनेक्ट करेंगे. तो आपका डायोड क्या होगा, आप उसको फॉरवर्ड बायस कंडीशन में कनेक्ट कर सकेंगे. ओके, सो what is the statements in given, that is, although there are number of SM pack, that is surface mounted package styles, two basic styles dominate the industry, that is surface mount and small outline transistor. That is, one is the surface mount and second one is the small outline transistor. So these are the picture of surface mount diode. Okay, so the length and width of surface mount package are related to the current rating of the device, and the larger the surface area, the higher the current rating. So उसका surface mount का जो करंट रेटिंग है वो किस पे डिपेंड करता है, उसके सरफेस एरिया पे. ओके, जितना उसका सरफेस एरिया ज़्यादा होगा उतना ही उसका करंट रेटिंग भी ज़्यादा मिलेगा. ओके, सो for surface mount diode rated at 1 ampere might have a surface area given by 0.181 by 0.115 each. So ये एक स्टैंडर्ड है कि भाई आपका अगर 1 एम्पियर का रेटेड डायोड है तो उसका साइज कितना होना चाहिए. तो ये साइज यहाँ पे दिया गया है. अगर आपका 3 एम्पियर का डायोड है तो उसका साइज कितना होना चाहिए, दैट इज द 0.260 in 0.236 inches. Okay, and the thickness tend to remain about 0.103 inch for all current ratings. उसकी thickness same रहेगी. Okay, but surface area will going to be increased as the rating is going to be increased. Okay, now increasing the surface area of surface mounted style diode increases its ability to dissipate heat. अब जितना भी आपका एरिया ज़्यादा होगा उस तो उससे क्या होगा कि जो हीट डिसिपेशन होता है, कोई भी पावर इलेक्ट्रॉनिक्स डिवाइस जो रहता है उसमें क्या होता है कि जब करंट फ्लो होता है तो उसमें हीट जनरेट होता है. तो वो उस हीट को एक लेवल से ज़्यादा हम नहीं बढ़ने दे सकते. अगर वो एक लेवल से ज़्यादा बढ़ गया तो क्या होगा, वो जो कंपोनेंट हो दैट इज गोइंग टू बी डैमेज्ड और इट्स कैरेक्टरिस्टिक इज गोइंग टू बी अफेक्टेड. सो ये जो ज़्यादा सरफेस एरिया है वो क्या हेल्प करेगा, जो हीट वहाँ पे जनरेट हो रही है उसको डिसिपेट करने में उसको हेल्प करेगा. ओके, सो increasing the surface area of surface mounting style diode, increasing its ability to dissipate heat, and also the corresponding increase in the width of the mounting terminals increases the thermal conductance to virtual heat sink made up the solder joints and mounting lands. Okay, so these figure is for the SOT यहाँ पे क्या दिया दिया गया है सर. SOT का फुल फॉर्म हम एक बार देख लेते हैं. SM that is stands for surface mount, or SOT that is stands for small outline transistor. Okay, so surface mount diodes and small outline transistor, two things are given over here. So this is the small outline transistor. What is difference in it? There is a two pins already that is similar with that diode, but over here there is a mounting leads is one more pin is given there, that is pin 1, pin 2 and pin 3. In that case सिर्फ दो पिन थी, लेकिन SOT में क्या होगा, तीन पिन हमको मिलेगी. There is a three terminal transistor package commonly used in SM diodes. Okay, so this is the basic difference, and where and why this differences occur, you can see the terminals are numbered counterclockwise from the top, pin 3 being alone on one side. However, there are no standard markings indicating which two terminals are used for the cathode and the anode. Okay, so यहाँ पे आप किसी को भी कोई मार्किंग नहीं होता है, तो आपको उसको टेस्ट करके लगाना पड़ेगा. Okay, now some SOT style packages include two diodes which have a common anode or common cathode connection at one of the terminals. Now the small size also makes it impractical to label them with identification codes. As with many of the tiny SM devices, you have to determine the pin configuration from other clues on the circuit board and schematic diagram. तो आपको other clues और schematic diagram का use करके उसको कैसे circuit में implement करना है वो आपको जानना होगा. ओके, नाउ दिस इज वन पॉइंट गिवन, दैट इज व्हाई डू स्टडी डायोड सर्किट्स, कि भाई हम डायोड सर्किट्स को क्यों स्टडी कर रहे हैं. तो देयर आर सो मेनी एप्लीकेशंस ऑफ डायोड्स इन आवर इलेक्ट्रॉनिक इंडस्ट्रीज. So most electronic system like TVs, audio, power amplifiers, computers need a DC voltage to work properly. ये सभी जो चीज़ें हैं वो DC voltage पे work करती है. Okay, now since the power line voltage is alternating and normally too high of value, we need to reduce the AC line voltage and then convert it into a relatively constant DC output voltage. Now the selection of the electronic system that produces this DC voltage is called the power supply. So ये जो पावर सप्लाई हम डिज़ाइन करते हैं उसमें भी हम पूरी डायोड सर्किट का यूज़ करते हैं, जिसे हम रेक्टिफायर के नाम से जानते हैं. That portion we are will also going to study. But before to understand the performance of operation of rectifier, we must study the diode, because only once we know the basics of diode, then we are going to understand how the rectifier is work, how it will useful in real practical things. Okay, so that's why we need to study the diode circuits. Okay, so student, today we will discuss up till that. In next lecture we will go for further discussion with the another topics. Okay, thank you. So students, finally, as in every lecture, after completion of every lecture, I will try to give you a message that please remember turn off the light when it is not required. Okay, so please save the energy, save the electricity. Thank you very much.